In this lesson, we're going to start looking at how we can graph negative values. Every graph we've looked at so far, every number has been positive. But that doesn't always have to be true. There's lots of good examples where we have negative numbers. For example, the first one here, we're going to talk about temperatures. Obviously, here at home, we have negative temperatures come winter. So that's a great example of how we can talk about negative numbers in terms of a graph. Let's take a look at this example. The temperatures at 2 a.m. and 4 a.m. on a winter day are recorded in the table below. Okay, so they give us 2, they skip 3, and they give us 4 again, and we're missing 5. If the relationship between temperature and time is linear, so it's following a pattern, what are the temperatures at 3 a.m. and 5 a.m.? So I have to, in a way, kind of guess, but I have to make sure that it follows a pattern. So for instance, if I did this, from negative 8 to negative 6 would be up 2, and then up 4. Well, we know that's not linear. Things that are linear have the exact same numbers for your ups. So what number does this have to be? Well, if I put negative 5 in there, I went up 3, then up 3 again. And if I go up 3 again one more time, I get up to the positives. There's my pattern. Okay, we want to graph this relation. Here's a good old graph. Notice that I made this graph look a little bit different this time. Well, why? Well, we got our temperatures down here. Oh, sorry, this is time down here. Time. Temperatures up the side. Okay, I didn't put another axis in here because I actually have to think about this. Okay, I have negatives this time. So negative 8 to positive 1, if I think of this as being 1, 0, negative 1, negative 2, and so on down the bottom here, and my axis, where 0 is actually up there. Okay. What times did we start? We started at 2 a.m. So I'm going to put 2 a.m. I'm going to put it right here. Okay, this is 2 a.m. So I'll label it like that. And then I'll call this one 3 a.m. So you really should label your axes. Even if your axes are kind of in the middle of the graph, you can do that. 5 a.m., 6 a.m., and so on, right? Okay, if we graph our data, what do we know? 2 a.m. is minus 8. At 3 a.m., it went up 3 degrees, it's minus 5. Just right there. It went up 3 more degrees. And then it went 3 more degrees. It's following a pattern. Linear things follow a pattern to make straight lines. That's kind of our big idea. Okay, but this time we had some negative things. Can I write an equation for this? Absolutely. Okay, x is the time since 2 a.m. That's where we started. Y is our temperature. What do we know we started at? We started at minus 8. And we're going up 3 degrees every hour. Okay, same things we've always done. There's nothing different except we have a negative value in here. We've actually had negative rates before, just not negative initial values. Let's take a look at another example. We've got Joel. He has a summer job cutting lawns. The relationship between his profit and the number of lawns cut is shown with the graph below. Okay, what type of variation is relationship and what is its initial value? So this is a pretty easy one. You can tell by our initial value we're down here at negative 100. Well, what have we always said with initial values? If we have one, that means it's a partial relationship. What is our initial value? It's negative 100. Okay, now, not that they asked us this, but why would you have a negative value as a negative number as initial value? Well, if he has a lawn cutting business, he's going to have to buy some stuff before he can actually go to work, right? He may have to pay for his mower or some gas or something before he can actually cut a lawn. So he's invested some money, which means he's in the hole to start. He's got to earn his money back as he works off some lawn. Okay, let's try another one. Information with the volume of a particular gas and its temperature is shown in the graph. Which of the following is true with the information represented in this graph? So some of these gases have temperatures that are negative. As we said, temperature is a good example of negative numbers. Okay, and their volumes depend on what the temperature is. So what do we got here? We got some choices. The volume of the gas is less at R than at P. The volume of the gas at R is 4, and the volume of the gas at P is between 0 and 1. I'm going to guess 0.5. So it definitely can't be that. The volume of the gas is greater at Q. The volume of the gas is 2 compared to 4. Which is greater? I don't think Q is greater, so that's definitely. The temperature, okay, temperature now, of the gas is lower at P. Well, what's our temperature? It's negative 100 and something. And temperature at Q is positive 100 and something. So I would think that this makes sense, right? The gas is lower at P. Negative numbers are smaller, they're lower than positive numbers. Just to make sure, let's try the last one. The temperature of the gas is higher at Q than at R. Well, I think R actually has a higher temperature. It's somewhere around 500 and something compared to 100 and something. So definitely C being right. And again, temperature is a really good example of something that can be negative. All right, last idea here. When we take our axes and extend them in both directions, we create a plane. Okay, so normally we've always had this. That's our graph. Well, now we're going to go this way and this way. Okay, this is still going to be our x's, like they always have been. This is still going to be our y's, like they always have been. When I go to the right, I get positives. When I go up, I get positives, like we've always had. But we can also go to the left into the negatives and down into the negatives. If you do that, you're going to get this nice, beautiful graph like we have down here. On this graph, the center point, this one right here in the middle, it's called the origin. It has coordinates 0 and 0. Okay. The first thing is always your x, like it always has been in our table, and the second thing is always our y, like it's always been in our table. When you go to the right, you get new coordinates. We'll call this one 1. I've gone to the right 1, but not up or down. When I go to the left, it's negatives, but not up or down. If I go up, I haven't gone left or right at all, so 0, and positive, I've gone up 2. And if I go down, we haven't gone left or right at all, but we've gone down 3. So the first number is your left and right, and the second number is your up and down. So for instance, if I want to graph 2 and 1, where would that be? I go 2 to the right and up 1. Go over 2, up 1. We'll call that point A. If I want to find negative 3 and negative 2, I'd be going left because it's negative, and then down because it's negative. So left 3, down 2, we'll call that one B. And let's try C here. I have negative 1 and 4. Where would that be? Left for negative, up for positive. There it goes, C. Okay, so the first number is your left and rights. The second number is your ups and downs. Let's give some of these a try. Can you figure out my coordinates for me? Okay, so counting from 0, 0, we always start by going left to right first. So over 1, 2, 3, 4 to the left, and down 1, 2, 3. A has to be left 4, down 3. How about B? Starting from 0, 0, left 2, up 2. So left 2, up 2. Okay, so for C, we're going to the right this time. 1, 2, 3, 4. 4 to the right, and then up. 1, 2, 3. They're both positives. Okay, we'll try D. 1 to the right, and then down 1, 2. And we'll try E. 1, 2, 3 to the right. We didn't go up or down at all, so it's a 0. And if we try F, I didn't go left or right at all. I just go up. So 1, 2, 3, 4, 5. And there's my points. Okay, so we're going to start graphing some things on this plane. We call this the Cartesian plane, the fancy name for it. Okay, make sure you do left and rights first, and then your ups or downs. Okay, you could have negatives or positives for both numbers, as we can see. Okay, give this sheet a try, and if you're stuck, come see me.